Hello science fans and welcome to SHE-ensya. Today, we're going back to basics and continue our discussion on animals, specifically the events that forced them to evolve. In our last discussion, we talked about how animals have roamed planet Earth for about 500 million years. We also discussed what we know about the history of animals based on the fossil record from the Earth's 4 known eons. And as we walk through Earth's memory lane, we also passed by the 5 mass extinction events. The first mass extinction event was the Ordovician-Silurian extinction that happened 440 million years ago. The Ordovician period from 485 million to 444 million years ago was a time of great dramatic change for life on planet Earth. Over a 30 million year stretch, species diversity blossomed. But as the period ended, the first known mass extinction struck. At that time, an ice age locked up huge amounts of water in an ice cap that covered parts of a large southern polar landmass. This icy period is believed to have been triggered by the rise of North America's Appalachian Mountains. The large-scale weathering of these freshly uplifted rocks sucked out a lot of carbon dioxide from the atmosphere and drastically cooled the planet.
The cold never bothered me anyway.
As a result, sea levels went down by hundreds of feet. Creatures living in shallow waters would have seen their habitats cool and shrink dramatically, which very few were able to adapt to. Add to that how the remaining life forms needed to adjust to chemically hostile waters. Because once the sea levels started to rise again, the marine oxygen levels dropped, and this caused the ocean waters to more easily hold on to dissolved toxic metals. The Ordovician-Silurian extinction is the second worst mass extinction known to science. This event killed an estimated 85% of all species. The event took its hardest toll on marine organisms, such as corals, shelled brachiopods, eel-like creatures called conodonts, and the trilobites. The second mass extinction event was the Devonian Extinction that occurred 365 million years ago. Starting 383 million years ago, this extinction event wiped out 75% of all species in a span of 20 million years. In several pulses across the Devonian, ocean oxygen levels dropped precipitously, which dealt serious blows to conodonts and ancient shelled relatives of squid and octopuses called goniatites. The worst of these pulses was called the Kallwasser event that happened about 372 million years ago. Rocks from the period show that as oxygen levels plummeted, many reef-building creatures died out, including a major group of sea sponges called the stromatoporoids. It's been hard to nail down the cause for the late Devonian extinction pulses, but volcanism is a potential trigger.
Live long and prosper.
Because within a couple million years of the Kallwasser event, a large igneous province called the Vili Traps erupted 240,000 cubic miles of lava in what is now Siberia. The eruption would have spewed greenhouse gases and sulfur dioxide, which can cause acid rain. Asteroids may also have contributed, because after all, Sweden's 32-mile-wide Sillien crater, one of the oldest surviving impact craters on the planet, was formed about 377 million years ago. Though it may sound surprising, land plants during the Devonian may have been accessories to the crime as well. The plants during the Devonian also hit on several winning adaptations, which includes the stem-strengthening lignin and the vascular system. The widespread growth of trees would have sucked out a lot of carbon dioxide from the air, which would trigger a global cooling event. And this would stress out organisms have completely adapted to the existing environmental conditions. The plants also started getting bigger and their roots to grow deeper, which would have increased the rate of rock weathering. The faster rocks weathered, the more excess nutrients would flow from the land to the water. The influx would have triggered algae growth, and when these algae died, their decay removed oxygen from the oceans to form what are known as dead zones. To add to the puzzle, apart from massive species dying out during the Devonian, species diversification also slowed down. The slowdown may have been caused by the global spread of invasive species. High sea levels during the time could have possibly let creatures from previously isolated bodies of water to mix and mingle, leading to the homogenization of marine ecosystems all over the planet. The third big extinction event was the Permian-Triassic Extinction around 252 million years ago. Some 252 million years ago, life on Earth experienced the Great Dying, which is the other name for the Permian-Triassic Extinction. The cataclysm was the single worst event life on Earth has ever experienced. In a span of over 60,000 years, about 96% of marine species and about 75% of land species died out, and it took the marine ecosystem 4 to 8 million years to recover. The world's forests were wiped out and didn't come back in force until about 10 million years later. Of the 5 mass extinctions, the Permian-Triassic is also the only one that managed to wipe out a large number of insect species. The extinction's single biggest cause is the Siberian Traps, an immense volcanic complex that erupted more than 720,000 cubic miles of lava across what is now Siberia. The eruption triggered the release of at least 14.5 trillion tons of carbon, more than 2.5 times what would be unleashed if all the fossil fuels on the Earth would be dug up and burned right now. Adding insult to injury, magma from the Siberian Traps infiltrated coal basins on its way towards the surface, probably releasing even more greenhouse gases such as methane. The resulting global warming event was hellish. In the million years after, seawater and soil temperatures raised from 35 to 40 degrees Celsius. By 250.5 million years ago, sea surface temperatures at the equator got as high as 40 degrees Celsius, a hot tub standard maximum temperature. And at that time, almost no fish lived at the equator. As temperatures rose, rocks on land weathered more rapidly, hastened by acid rain that formed from volcanic sulfur. And just as in the late Devonian, increased weathering would have led to anoxia, or decreased oxygen levels that would have suffocated the oceans. Climate models suggest that at the time, the oceans lost an estimated 76% of their oxygen inventory. These models also suggest that the global warming event and the oxygen loss of the oceans account for most of the extinction events that happened during the Great Dying. The fourth mass extinction event happened 210 million years ago during the Triassic-Jurassic extinction. Life took a long time to recover from the Great Dying, but when it did, it diversified rapidly. Different reef-building creatures began to take hold, and lush vegetation started covering the land, setting the stage for a group of reptiles called the archosaurs, the forerunners of birds, crocodilians, pterosaurs, and the non-avian dinosaurs. But about 201 million years ago, life endured another major blow. The Earth experienced an 80% loss of species due to the quadrupling of carbon dioxide levels in the air. The Earth warmed an average of between 5 and 11 degrees Celsius, and this was probably triggered by huge amounts of greenhouse gases from the Central Atlantic Magmatic Province, a large igneous province in central Pangaea. Remnants of this ancient lava flow can be found in South America, Eastern North America, and West Africa. The lava flow was so extensive that it can cover the entirety of the United States of America with a quarter-mile of lava rock. The uptick in carbon dioxide acidified the Triassic oceans, making it more difficult for marine creatures to build their shells from calcium carbonate. On land, the dominant species back then were the crocodilians, and they were much larger and more diverse than what they are now. Many of them died out, but in their wake, the earliest dinosaurs, small, nimble creatures at the ecological periphery, started to diversify. The fifth mass extinction event was the Cretaceous-Tertiary extinction that happened 65 million years ago. The Cretaceous-Tertiary or the Cretaceous-Paleogene extinction is the most recent of the 5 extinction events, and it is the only one that is definitively connected to a major asteroid impact. Some 76% of all species on the planet, including all non-avian dinosaurs, went extinct.
No! No!
One day, about 6.6 million years ago, an asteroid that was about 7.5 miles wide hit the waters of what is now the Yucatan Peninsula at a speed of 45,000 miles per hour. The massive impact, which left a crater more than 120 miles wide, flung huge volumes of dust, debris, and sulfur into the atmosphere, bringing on severe global cooling. Wildfires ignited on land within 900 miles from impact, and a huge tsunami rippled outward from where the asteroid hit the planet. Overnight, the ecosystems that supported non-avian dinosaurs began to collapse. These 5 major extinction events drove the evolution of animals by changing the environment so drastically that it only allowed the few organisms who were capable to adapt to survive. Mass extinction events like global warming and global cooling, or even asteroid impacts, prune whole branches of the tree of life, either through competition or trial by literal fire. But apart from death and destruction, the sudden disappearance of plants and animals that occupied a particular habitat also provides a unique opportunity for the surviving species, which is one of the reasons why we and other mammals were allowed to flourish on the planet after the dinosaurs went extinct. But Earth right now is once again experiencing a biodiversity crisis. Recent estimates suggest that close to 1 million species of plants and animals are in danger of extinction, in large part because of human activities such as deforestation, hunting, overfishing, and man-made climate change. Today, extinctions are occurring at 100 times faster than they would at the natural rate. And if all species currently designated as critically endangered, or vulnerable go extinct within the next century, and if that rate of extinction continues without slowing down, we could approach the level of a mass extinction in as soon as 240 to 540 years. And that is so much faster compared to the million years it took for the other 5 mass extinction events. And this time, it will also be our fault. And that's it for today's episode that discusses the major extinction events that drove the evolution of animals. Just remember, the first mass extinction event was the Ordovician-silurian extinction that happened 440 million years ago. And here, small marine organisms died out, probably because of an ice age. The second mass extinction event was the Devonian Extinction, which happened 365 million years ago, which wiped out a lot of marine tropical organisms, but we really don't know why. The third big extinction event was the Permian-Triassic Extinction, aka the Great Dying, around 252 million years ago, which was the largest mass extinction event in Earth's history, caused by the eruption of the Siberian traps. The fourth major extinction event happened 210 million years ago, with the Triassic-Jurassic Extinction. This led to the death of many crocodilian species that led to the rise of the dinosaurs. And finally, we have the fifth mass extinction event, which was the Cretaceous-Tertiary extinction that happened 65 million years ago that wiped out the dinosaurs because of a massive asteroid strike. I hope you were able to learn something from our discussion of the Earth's mass extinction events. And I hope it gave you the opportunity to reflect on your lifestyles so that we can change and not cause the sixth big one. Now, if you did, I hope you can give this video a thumbs up and also subscribe to our channel. If you have any comments, questions, or suggestions, please don't hesitate to message me, your resident Filipina scientist, in the comment section below. Thank you very much, and see you around!